Hey guys, we're in the home stretch. A couple more lessons to teach you. This one today is called double angle identities. So I'll leave this sort of on the screen for a second. You can pause, you can copy it down. There is one formula for the sine of the double angle, right? That is right here above this line, right? That's the sine of the double angle. And then down here for the cosine of the double angle, you have three possible formulas, all right? None of them is better than the other. They're interchangeable. It just kind of depends on what you're given, right? Sometimes you're given cosine and sine, so go ahead and use this formula. Sometimes you only have cosine, use this formula. Sometimes you only have sine, use that formula. Okay, so I'm gonna leave this here on the side so we can refer to it. I'll pull it back in as needed. So this is what your problems are gonna look like. They're going to give you the sine or the cosine or the tangent of some angle, and they're going to tell you where it is located. This is really important for positives and negatives. So this particular angle is between 90 and 180. So let me just draw a really fast picture. That means somewhere here, I found the angle. It's in this quadrant, okay, between 90 and 180. Sometimes those are given in radians, but that's okay. You can do that too. All right, so if that's the angle and the sine of it is 3/5, sine is opposite over hypotenuse, which means this missing leg of this right triangle has to be 4. But here's the really important part, like unbelievably important. This is negative in this quadrant, right? If I was trying to name this ordered pair, it wouldn't just be 4, 3, it'd be negative 4, 3. That's why that's negative. So now that I have that labeled and I'm trying to find the cosine of the double angle, here's my formulas. I'm gonna pick one. Now, and again, I can pick any one of these three, but look at what was given, right? The sine was given. I think I probably should just go ahead and pick this last formula. Let me write this down. So I'm going to use 1 minus 2 sine squared theta, all right? And I'm going to plug in what I know. I know that the sine is 3/5, and I do have to square it, okay? And here's the good thing, too, about using that formula. I'm not guessing here. I didn't calculate anything here. This was given where like maybe I missed the negative, right? I could really screw things up. So let's see, this is 1 minus 2 times 9/25. This is 1 minus 18/25. 25 minus 18, I believe, is 7/25. Okay, so let's try another one. Okay, so here we go. Check this out. All right, so this is also between 90 and 180. Okay, the sine value is 1/2, so that's 1/2. Oh, hey, wait, isn't this one of those ones that's on the unit circle? Isn't there a point over here that has a sine value of 1/2, and isn't then this negative rad 3/2? Oh, it is. So hey, check it out. I've got the cosine and the sine from the unit circle. All right, so let's find the sine of the double angle. Here's the formula. That means I need 2 times the sine times the cosine. 2 times the sine of the angle times the cosine of the angle, which I know right here from the unit circle. So let me plug those in. The sine value is 1/2. It was also given. Cosine value is negative rad 3/2. Notice that negative is really important here. Multiplying this together, that 2 would cancel with that 2. I end up with negative rad 3/2. All right, that's the whole lesson. I'm available for office hours this week. You can check out my website for potential dates. Talk to you soon.